Welcome to this video. Today I'm going to be showing you a quick tutorial on how to set up the bus servo motor ST3215 by the company Waveshare. I personally got these motors from my robotics project, in which I had a robotic arm that was trying to draw a circle. I was just using simple, cheap servo motors, but the resolution just wasn't good enough. That's why I decided to upgrade to these. But without further ado, let's get started with this tutorial. I will be using two pieces of hardware, the motor itself and the bus servo adapter board. We're going to be talking to this adapter board via USB, and it's going to be translating our commands to the motor. The way these motors work is that they have internal memory addresses. Each address is responsible for a certain feature of the motor by writing to these registers without the motor to move. For the hardware connections, we're going to be connecting the motor to the adapter board, an external power supply, in this case I'm using a 12-volt power supply, and finally a USB-C cable to the computer. Next step is for us to go to the website of Waveshare, and there you can find very good documentation for both the motor and the adapter board. I'll put a link to both of these pages in the description of this video. In the adapter page, if you scroll down to software, you can click on the library for Python and download that. Now, in the motor page, if you scroll down to the bottom, you can see in the FAQ, they posted a Excel spreadsheet containing all the memory addresses of the motor. Download that because it can be very useful later. Next, we're going to be opening a code editor of choice. In this case here, I'm going to be using VS Code. I first create an empty folder just for this. Open that into VS Code, and then I'll just drag and drop the Python library that we downloaded to this folder that we just created. Alright, next I'm going to be using some terminal commands over here. We're going to move to the folder we just copied using the cd command, and there notice there's a requirements.txt file, and we need to install those dependencies. So let's go ahead and create a virtual environment in Python. We do that with this command over here, python3 -m venv, and then the name of the environment you want to create. I did .venv. And then we can see that we created this new folder there, which is going to be containing our Python virtual environment. To activate it, we're going to use this command over here. We do source, and then we do .venv/bin/activate. That's going to make us go inside this virtual environment. And now we can install the dependencies that are described in our requirements.txt file, that is with the command pip3 install -r requirements.txt. And now all of our dependencies are installed in this contained virtual environment. So everything we need for this project is just here. Now, if we explore the library that we just copied over, we can see here that there are a few folders. And there's two types of them. There's this SCSCL one, as well as this STS one. And that is important because at first I did a mistake of using the wrong folder for my motor. So you got to make sure you're using this STS folder here. That's going to contain the Python files that are specific to the ST3215 servo motor. For this tutorial, I'm going to be using the file read_write.py. I think that's a good example because it shows you how you can read and write the addresses of the servo motor, and it gives you a very good understanding of how everything works. If you look here in the beginning of the file, we see some important parameters. And we're going to be changing only one of them. That's this device name here. And that is pretty much just saying what's the path of the USB device you connected to your computer. Just telling where can I find the motor or the adapter board that you connected to me. And it's going to be different for different operating systems. I'm here in macOS. So for me, I got to use this command over here. I do ls/dev/tty*. And I'm going to be looking for everything that has a USB in it. So I found here the name of the device that I connected to my machine. And I just copy that over there and replace the placeholder string. If you're using Windows, you can just open PowerShell and run this command over here. It should give you the different USB ports. And it should look something like COM1, COM2, COM3. You can play around, maybe unplug the device and plug it back in and see what changes. And maybe that way you can find which port you're using. In Linux, it's similar to macOS. You just run this command over here, and it's going to list all of your USB devices, and you can also try to figure out which one you just connected. Alright, so now we can understand better what this file here is doing. If we scroll down to the file, we can see that there are two loops that are running. And within the first loop, we're going to see this line over here. This line is trying to talk to the motor and tell them to move to a certain position. It's going to give the speed as well as a desired acceleration. And again, under the hood, this is writing information to the memory addresses in the motor, and it's going to tell them to go. In this inner loop here, we are going to be reading information from the motor as it moves. In this case here, we're going to be reading position and the speed as the motor moves until it stops, at which point we can go back to the outer loop. In this example file, it defined 2 positions for the motor, and then every time you press enter, it's going to be switching between the 2 positions. So let's try to actually run this script over here. I'm going to move now to the folder in the terminal here, ST Servo -env /sms sts. That is the folder where the scripts are for this motor. And there we can find our read_write.py file. So I'm going to run python 3 read_write.py, and that should start our script. I then need to press enter here to start, and then the motor should start moving. Now, if we look back into our file, we see that we wrote the position using this method here. This file is located also in the library that we copied, and there it does the under the hood work. We see here the write position method that we used actually writes to a certain address of the motor. We gave the position, the speed, and the acceleration that we wanted, and then we write it to this address here. It's address number 41. If we now go to the Excel spreadsheet that we downloaded earlier, we see the address 41 here is the acceleration. And you can see that after that we have the target location, the operation time, and operation speed. So we're actually writing 7 bytes worth of information to address number 41, which is going to take care of the target location, the operation time, and the operation speed. We only care here about the target location to make the motor move somewhere, but we write all that information to the address 41. Now going back to the Python file, we use this line here to read the position and the speed from the motor. And we can see now that if we click on the method, we go back to our library that we downloaded, and there, that's the method that we call. And you can see here we are reading 4 bytes from a specific address. By clicking on this constant here, we can see that the address is actually number 56. Again, we go back to our spreadsheet and go to position 56, and there we can see current location and current speed. So if you read 4 bytes starting from position 56, we're getting information about the location and the speed of the motor. But that's pretty much all that I had for this video. I hope I could show you the basics of working with bus servo motors, and I leave it up to you to look at the other files in this library and try to make the motor move in different ways, put the motor into different modes. In this example here, it's moving as a wheel. It's just constantly moving without caring about the position that much. It can turn directions. But that's it. Thanks for watching, and I'll see you in the next video.